The graph below shows a rectangular sum of n equals 8 rectangles to approximate the area under the line from x equals 0 to 4. So, all right, so we're trying to estimate the area under the line. So, all of this area here. So obviously we're missing some, aren't we? We have these gaps. So that's why it's an estimate. It's not exact. We're approximating the area using rectangles. So they don't fit exactly to the line. They don't fit tight to the line, so it's just an estimate. Anyway, this is what we do. So is this first off a right-hand or left-hand sum? This is a left-hand sum. Now why? Why is it a left-hand sum? Well, because each of these rectangles is hitting the line on its upper left corner, upper left corner, etc. They're all hitting the rectangle on their upper left corner. What's the equation of the line? Well, notice this line goes through 0. So, the equation of a line is y equals mx plus b. The b is what we call the y-intercept. It's where the graph hits the y-axis. This is the y-axis and the x-axis. It hits the y-axis at 0. So that part's 0. M, as you know, is the slope. What is the slope of a line? Rise over run. So, okay, so what's the rise and run? Well, this line goes let's go from any point to any point. Now, I'm not going to take like this point. Why? Because that's not clearly on a grid line. But I'm going to take a point right on a grid line. So like that one would be good. That's right on a grid line. And this one. So between those two, what's the rise and run? It goes up 1, 2, 3 over 1. Up 3, that's the rise. And the run is over 1. So that's 3 over 1, x plus 0. In other words, y is 3x. That's the equation of that line. Okay, now what's the value of the sum? Meaning the rectangles. It wants us to add up the rectangles, which is just going to be an approximation for the area under the line, but that's what they want. So how are we going to do it? Well, let me erase what we just did and go back to each of these rectangles. So this rectangle comes up to 1.5, right? And in fact, let me just put it right here. Comes up to 1.5. This rectangle comes up to 3. This one comes up to 4.5. This one comes up to 6. This one's coming up to, what is it, 7.5? Given the heights here. This one comes up to 9, and this one comes up to 10.5. That's how high they are. But notice each of them only have a width of half a unit. Here, let me do the next one. See this next one here? Try to do it more precisely. See that little rectangle right there? It's only half a unit wide. So each of these rectangles is half a unit wide. The area of a rectangle, I'm sure you know, every rectangle is just length times width, just one side times the other side. So each of these rectangles, so the first one's going to be 1.5 times 0.5, right? Because this rectangle right here, its area, it's 1.5 high, 0.5 wide. The next rectangle right here, that one's going to be 3 high, again, 0.5 wide on the bottom, etc. The next one, 4.5, 0.5. I'm going to go dot, dot, dot. Now, do you realize they're all going to have a 0.5? So what would save time would be to factor the 0.5 out and then just add up the heights, 1.5, 3, 4.5, 6, because they're all going to be multiplied by zero point 0.5 width, aren't they? So just put the 0.5 in front of all of them as a multiplier. Factor it out, in other words, we call that. And then just add up all the height just to save time. That'll be quicker. So then, just you can go use Desmos or something. I'm just going to say 4, what's that? 4.5, 9, 15. It's at 22.5. What's that? 23, 33, 43, 42. Half of 42, 21. Yep, that's the answer. Use Desmos as you need to. So what is that? That's the area of all of these rectangles. All of these rectangles areas add it up, which is an approximation of the area under the straight line. Not quite. It's an underestimate, right? Because it's missing some gaps. But there we go.